Okay, in this video we're going to continue talking about iterables. We talked a little bit in the last video about generators and iterators. The idea of an iterator is a collection of items that has a beginning, and you can iterate from one item to the next, and it may or may not be infinite. If it's a finite collection, then you can iterate through each one of the items until eventually you get to the very last item, and then iteration is complete. There are infinite series in which you can continually iterate indefinitely. And last time we talked about the Fibonacci numbers, and we're going to go into prime numbers at some point here. So I've got we're going to talk about a couple other iterables we use in Python all the time. So the range function produces an iterable, and so does the map function. We use these a lot, so let's take a look at that. I have a simple file called rangeandmap.py. Little print statement lets me know everything's working right. I made this tprint function last time, and it's just a quick way to print out the type of an item and the item itself. So I'll use this a few times. And here we're going to talk about the range object. So what I have is a range object that goes from 1 and the starting point. The second parameter here is the ending point, and the third parameter is the increment, right? So this produces an iterable that goes from 1 to up to 10, but not including. So the ending point is never included. So this is a starting point is inclusive, the ending point is exclusive, and then an increment by 2. So this is going to produce an iterable that iterates from 1 to 3 to 5 to 7 to 9, but then once we get past 9, we're beyond our ending point, so it stops. All right, so let's take a look at this R. I'm storing this in a variable called R. So we can go up to our terminal, and again, you can run this with Python 3, right? Or if you have the executable bit set, which I do, and use the hashbang, which I do, you can run like this on Linux and Unix machines. Okay, so we have our range object, and notice when this prints out, it just says range. Okay, so this is not technically an iterable, because if it was an iterable, I would be able to say something like this. Let's say the result is we're going to get the next item from range, right? So we always use next, this global next function, to get the next item from an iterable. And so if I try to tprint this, the result, we get this error, right? The range object is not an iterable, right? So let's take a look. If I actually wanted to look at this as a list, right, I can say something like this: li equals list of the range function, and then tprint that. All right, so that gives us a list, but when we try to directly iterate, see, so the range object itself is not an iterator. So that's kind of strange, because we can see, with the for loop style function, for I in our range value, we can do something like print I, right? And let's go ahead and label this. Let's say this is for loop 1. I'm going to comment this out again so we don't get that error message. So for loop 1, we're iterating over our range object, right? This is the same range object. Okay, and we see we are able to iterate over it. So what does that mean? Well, it turns out the last time we talked about generators, I left out, for the sake of simplicity, I left out one thing. When we look at a while loop, iterating, this was sort of the while loop we had, and so we were comparing that to this for loop, right? So anytime you have a for loop, you're actually doing something like this. You have a try statement. You're going to try to iterate through this loop. While it's true, you get the item and you call next on your iterator repeatedly until you get this stop iteration exception, right? So there's one step that I left out, and that step is to try to convert the thing into an iterator first, right? Generators immediately produce iterators, so we didn't need to do that there. But in this case, we do need to actually create an iterator with the iter function. So that's the part that's missing here, right? And I'm going to go ahead and comment this out, and we're going to get to this in a second. Now, we just printed out for I in range, and we can do this multiple times, right? The iterator, we're creating a new iterator each time, right? Because we saw that the iterator could be exhausted. And previously here, we saw the iterator would be exhausted once stop iteration occurs, and then anytime we try to get the next item from it, we would keep getting the stop iteration error, right? So the iterators go to the end and they don't ever start again. All right, so that's sort of the problem here. We do want these to start repeatedly, so that's why these are not iterators. We want to create an iterator from this range object. And we see I can have two for statements exactly the same in a row from the exact same range object, and we see we're going to get two printings of that value is iterated through 1, 3, 5, 7, 9, 2 different times, right? So this in and of itself can't be the iterator. So what we're actually doing here, and we can print this out as a list as well. We can see what this looks like. You know, li. It should be the same. This is for loop 2. Right, printing out the same thing. Actually, I'll do the for loop 3. But the idea here was that we do indeed see that we can iterate over this range object multiple times. So it's not an iterator, but an iterator can be created from it. All right. So let's try to take this while loop that we were looking at before. We're going to reconstruct that, and we're going to see what's going on with this range object. So this is while one with our range object. Okay, so we basically just construct that little while loop that we had. We have to have the try except because there's a stop iteration exception that can occur, and we want to we can just copy and paste what we had here to make it quicker. I highly recommend you type things out. The more you type things out, the better you get at muscle memory and memorizing syntax and that sort of thing. But for the sake of the video, we'll use some copy and paste. While true, we're going to try to get the next item from something, right? And we know we can't do this, right? Because this is a range object, and we already know that's not an iterator. We can try it real quick, and we'll see we won't get a successful stoppage of the program, right? So we get this exception. Range object is not an iterator. It specifically states that. Okay, so what we have to do is get an iterator from that range object. So as it turns out, the way you can get an iterator from something is using the iter function, right? And that's sort of what we were talking about down here. Okay, so we're going to use this iter function and pass in our range object, and that should give us an iterator. Now, iter is a global function, just like next is a global function, just like length is a global function. And what this actually does is it looks on this range object, whatever object you pass in, and it asks it, hey, do you have a way to make an iterator? And then this object says, you know what I do, and here's an instance of the iterator. Okay, so this is a special method that you can actually add on to your objects, and we're going to do that down the road, and we make a class on prime producing, a prime producer class. We're going to have it create iterators. So right now, the range object is being passed in. We ask the range object, hey, do you know how to make an iterator? It says yes, and it gives us a brand new one at the starting point of its iteration. Now we can go through, and let's go ahead and t-print that just so we see that it is an iterator. All right. Then we can go through and iterate through it, each item, right? And so this would be item, right? One, 3, 5, 7, 9, and look, the range. Before we had a range object, right, from class range. This is class range iterator. It's a separate object that is iterable. It was built from the range object. Okay, so that's an important distinction. So now we can make as many of these iterators as we want, and from the one single range object. Okay, and if we had stop iteration here, we can, pass, or we can say print, stop iteration was encountered. All right, we go through. There it is. All right, so that's good. Let's do another while loop with a generator. So we'll say, and we've already talked a little bit about the generators. We've had an introduction. So this is while loop 2 with the generator. Okay, we're going to define a generator function. And with the generator function, we use the yield keyword instead of return. And I'm just going to do a simple generator. So this is going to give us an iterator when we call it. So generators always produce a generator object. So this is a generator function. When you call a generator function, it produces a generator, and generators are iterable. Okay, so that's sort of the terminology. So we're going to call the generator function, and it should give us a generator which is iterable. So that's why we called it IT. Okay, and we can, try the same sort of, scenario here. This code here, copy and paste. And so our iterator is from our generator there. And also, a lot of times, an iterator can be produced from another iterator. So I already have the iterator up here, and I could do something like, let's print the next item from our iterator. So that should print the number 1, right? And then pause the iterator, right? And then I'm making a new iterator. So this is a separate iterator, and I'm passing in the old iterator. Now when you do this, these are two separate iterators. I could say iterator 1. I have my first iterator, iterator 0, and iterator 1. Okay, and I can say something. First, let's just run this, make sure everything's working. We have two generators, right? They are iterable, but they so this one, it does in fact look like if you pass in the iterator itself, it does return the exact same iterator. So these two iterators are the same, and that's how we know that, because we can look at, this is effectively the location in memory where these items are located, and since it's the same memory address, we know that they are the exact same thing. Now different objects behave differently. Sometimes you can call the iterator on an iterator and it will give you a brand new instance of the iterator. Sometimes it will give you an iterator that starts at the very beginning of iteration. Sometimes it will give you a copy of the iterator at the same location. So you do have to be a little bit careful with passing in an iterator into the iter function. But you can test that out like we just did by printing out the type, or printing out the ID value, which is effectively the memory location. Okay. So we've got this idea here. We've got iter, and we can call next on this thing, right? And that should print out. It should print out 1, right? Now we go through this iteration, and so this should print out 2 and 3, and then we'll get stop iteration. Our iterator, while true, tprint item. Did I save it? So, oh yeah, it continued. So we printed out 1, then we got our generator objects, and then we got 2 and 3. So the iterator doesn't always start at the beginning. If you have retrieved some items from it, like this here, we retrieved the first item from our iterator. Then when we looped through it, we could do that with a for loop too. It would continue where it left off. It doesn't always start at the beginning, right? So the idea with an iterator is it has a starting point, and you can go one item at a time to the end if there is an end, but it does store that position. So once you take the next item, it doesn't automatically reset, right? So that's the whole idea of this iter function. Sometimes you need a brand new iterator, right? And so we could take iter, a new iter from our range object, and that would give us a brand new iterator from the range object that was starting at position 0. All right, so that's good. Let's check out the for loop version with this iterator. Let's try for I in GF. I'm sorry. This is the for loop for the generator function. And we can say for item in GF, and we can try to print this out. But again, GF, it stands for generator function. This is not a generator itself, so the generator function is not iterable itself. So we're going to try this though, but we should get an error. And when we run this, function object is not iterable. So there's that term again. Okay, so if we want to get an iterable from our generator function, we have to call that generator function, and it returns the generator, which is iterable. Okay, so we get 1, 2, and 3. Okay, so each time you call this function, it gives you a new iterator from the very beginning of iteration. All right, so that's good. What are some other things that are iterable? We have the range function. Something that we use a lot is the map function. Okay, so let's talk. It's an iterable, but let's take a look at what it does to start with. So what this does is it basically takes an iterable, like a list or something like that, and it maps a function to each value. And whatever the result of that function is for that value, that gets stored in another separate list, and that list is returned. So you're mapping data from one iterable, you're applying a function, and the results of that function go into another list, or rather another iterable that we can turn into a list. Okay, so let's look at the syntax here. Okay, so map is a global function. All right, it takes 2 parameters, lambda x. So this is a lambda function. You can pass in any function you want here, but this is a way to define a function quickly. This is a one-line function. So this is basically saying I want a function that has 1 parameter x, and my return value is whatever I put after the colon. So this could be something like x times 10. Okay, so this is a simple function. It takes in x as a parameter and then returns the value x times 10, right? Lambda. And I'll show that we can do this another way with just a regular named function here in a second. So let's pass in our range object, right? So that was range from 1 to 9 going by 2s, right? So this is an iterable. So the second item is an iterable. It can be a list, it could be a tuple, anything that you can iterate over, right? So this is our map, and it returns a map object. Okay, so class map. So this is a map object. All right, and we can see if it's iterable. One thing we can do is turn it into a list. Let's just say li equals list of m, and then we can tprint that. We know this should be type list, but what list does is it iterates over the entire object and puts each item in the list. Right? Now the difference between this map object and this list object is that this map object can produce the items one at a time, which means only one item needs to be in memory at a time. So if I have a map object that can map over 1 billion items, I don't need to keep all billion items in memory. Whereas if I have a list, I do have to have, if there's 1 billion items in the list, all billion items are stored in memory. Okay, so that's one of the benefits of these generators. It allows you to generate the values as opposed to have pre-calculated all these and take up all that memory unnecessarily. Okay, so it's a serious memory savings. So here we see we mapped the lambda function x to x times 10. So for each value in our iterable, we multiplied it by 10, gave us this map object. Then we iterated over that map object and produced a list, right? And our outcome was 10, 30, 50, 70, and 90, as we would expect, because our initial values were 1, 3, 5, 7, and 9. All right, so that's not bad. Let's take a look at another one. We will say map equals. First, I want to just demonstrate that we could have this function. It doesn't have to be a lambda function. Lambda functions are just one-liners. So I could define a simple function times 10 x and return 10 times x, right? And we can say map times 10 over the data in our range object, and we can print the list version of that. Let's do that here. And we should get the same result that we got up here. You don't really need a t print there. We know it's a list. All right, so we should get the same lists. Okay, so this is just a function. You can define it somewhere else. You can define it above, but if it's a small function, you can just define it inline with lambda x, and you can have potentially more values if you have a tuple. If each value of this list is a tuple, you could have an x and y. So if it was a 2 tuple, there would be 2 values in there. It's a little more in depth. All right, so let's iterate through this map object. All right, so print. This is map using an iterator. All right, m equals map. What do we want to do for this one? We will say lambda x, and we'll make it the negative value of x will be our return value. And what are we going to iterate over? Just to show that we can, iterate over the list of the range objects. So this should give us a list instead of just a range object. Either one is iterable. But if I do this, the entire range object will be expanded into memory, and then we'll iterate over it with this function calling each item, and that'll create a new list, right? But I'm basically just demonstrating that it's possible to do this. We don't really need to do it this way. So this gives us our iterator, or our iterable rather, and we say try, and we can get our iterator with the iter function, and we pass in m. Now m is our map. Again, basically this iter function is going to check with this object, and it's going to say, object, do you have a way of returning an iterator? And it's either going to say yes or no. And if it does, it's going to return a new iterator, right? And then we can t-print that iterator, see what that looks like. And we'll just pass on the exception right now. Okay, so we do get a map object. And let's see what happens if we just call next directly on the map object. So this is before we got our iterator. Okay, it gave us our first value. So as it turns out, the map object itself is iterable. And then when we call the iter function, since it's already iterable, it just returns itself. Right? So let's just see something. Let's look at both tprint_m and tprint are iterable. Okay, and they are the exact same object. Okay, so that's what I was saying with the iter function. Depending on the object, it oftentimes, if you already have an iterable, a lot of times it will just return itself. So it'll return the same value. So you see these values are the same, so we know this object is the same object. Both m and it are holding the same object. All right, and so we would just go through here and do another loop while true, and we get a result. Next value from Iterator, and then we can print that result, right? And then if we get a stop iteration, we can print something like that. All right. Okay, so that's the idea with these iterables. They tie in with next and iter, but the main idea is that you have a starting point, and you can go through. If it is a finite sequence, it will go and eventually at the end of the sequence raise the stop iteration exception. Otherwise, it will continue on indefinitely if it's an infinite series, right? And so we can use anything that's iterable with lots of different functions in Python. So if something's iterable, you can pass it into the list function, for example, and it will always iterate through that object, and it will produce a list storing all of the values of that iteration, right? The for loops, anything that's iterable, you can say for item in the iterable, and it will always iterate over that item. Okay, so iterables are something that are very, very common, and they show up a lot. So it's important to understand how iterables work. All right, I think that's enough for this video. So play around with range. You probably use that a whole lot, but probably a little bit more rare is map, but it's very powerful. It allows you to map one value to another, and it produces an iterable. So you can add that tool to your tool belt. All right, that's all I have for this video. Thanks for watching.